So in section 4.1, we learned how to solve systems of linear equations using graphing. Now we're going to talk about how to do it algebraically in section 4.4. So when we solve a system of two linear equations algebraically, there's two things we can do. We can either use the substitution method or the addition method. And it doesn't matter which method we choose, the ordered pair solution will be the same as long as we do our arithmetic right. So for the substitution method, what we want to do is solve one of the two equations for either x or y. It doesn't matter which one. Then we're going to substitute that expression that we get into the other equation for the appropriate variable. And you'll see what that means in a second. Then we solve that equation, and then we plug in the solution from that equation to the other equation to get our other variable. So how does that work? So step 1 in the list. Pick one of the two equations and solve it for one of the two variables. So I'm going to go with the first equation because that looks simpler. So x plus y equals 5. And it doesn't matter which variable we solve it for. So let's solve it for x. So solving for x means we want to get y to the other side of the equation. So we have to subtract it. And we get x equals 5 minus y. So what this equation, x equals 5 minus y, tells us is instead of calling the variable x, we can call it 5 minus y. It's just a different name for the same thing. So then we're going to go into step 2, and we're going to take the second equation, which was 2x plus 3y equals 7. And remember, we now have a different name for x. Our different name for x is 5 minus y. So we're going to put 5 minus y in where the x does. So 2 times, now this has to be in parentheses, 5 minus y plus 3y equals 7. Now, we solved these previously in chapter 3, or maybe chapter 2, I forget. So 2 times 5 is 10. 2 times the negative y is minus 2y, plus 3y equals 7. Remember, I just distributed the 2 to both things in the parentheses. Now, we combine our like terms. So for like terms, we have negative 2y and y. So we have 10. Negative 2 plus 3 is a positive 1y, and that equals 7. Now, the last step in solving for y is we subtract 10 from both sides. When we do that, we get y equals negative 3. Now, we know y equals negative 3. So let's go back and plug it into our other equation where we had sorry, that should be step 4. I kind of combined steps 2 and 3. So let's see. This one's actually step 4. Step 3 starts right. Nope. Step 3 starts where we start solving here. So step 4, we take that and we plug it back into our first equation, which was x plus y equals 5. So x plus a negative 3 equals 5, which really means x minus 3 equals 5. So add 3 to both sides, and we get x equals 8. So our solution is the point 8, negative 3. And of course we should check that. So let's see, check. We know it works for sure in the first equation because that's how we got our answer. Let's see if it works in the second one. So we have to have 2 times x, which is 8, plus 3 times y, which is a negative 3. And we need to know if that equals 7. So we have 16 minus 9, and we need to know if that equals 7. And the answer is yes, it does. So we definitely have a solution. So that's how we do the substitution method. Now let's talk about the addition method. Now notice it says only use the addition method if both equations are in ax plus by equals c form. So, do we have that? Yes. Something x plus something y equals another number. A number times x plus a number times y equals a number. So this system is set up perfectly for that. So when we do these, the first step is, if we need to, multiply one or both equations by appropriate non-zero numbers so that the sum of either the x coefficients or the sum of the y coefficients is 0. Then we add the equations, then we solve what's left, and then we substitute again, like we did before. So, let's see what we should do. For step 1, I have x plus y equals 5, and I have 2x plus 3y equals 7. So say I want my x variables to cancel out. If I look at the second equation, I have a positive 2 for the coefficient on x. That means I need a negative 2. And I have to multiply both sides of my equation by negative 2. The first equation, sorry. So when I do that, what happens? Well, if I distribute, my first equation is now negative 2x minus 2y equals a negative 10. And I haven't done anything to my second equation. Equals 7. Now, what happens if I add these two equations together? Well, I have a negative 2x plus 2x, so those go away. I have a negative 2y plus a 3y, which gives me a positive 1y. And I have a negative 10 plus 7, which is a negative 3. So, let's see, this one was, here's step 2, where I add the equations, and step 3 was kind of a bust. So step 4, we substitute. So we're going to plug y equals negative 3 into either equation. Well, I'm lazy, so I'm going to go for plugging it into the first equation because it looks like it's going to be less arithmetic. So we have x plus y equals 5. We're going to put that negative 3 in for y, remember? So x plus a negative 3 equals 5. Or really, x minus 3 equals 5. Add 3 to both sides. And we get x equals 8. So our solution is the point 8, negative 3. And of course, we could check that by plugging both values of the variables in for the second solution and for the second equation and making sure it works out. I'm not going to do that because hopefully you notice this is the exact same system we solved up in the practice problem for the substitution method. So we will leave it at that. And we will talk about how to solve word problems using systems in the next video, which will be the second part of section 4.4.